seats on the head table. You want to use this machine?
Take this.
Yeah, good morning, all of us. Yeah, my name is Sharmugam Shivakumar. I'm working as Head of Advanced Engineering and Technology in Mahindra & Mahindra, Mahindra Research Valley. I think each one can introduce. Can start.
Hi. Yeah, hi, good afternoon. I'm Shajeev Surendran. I head the customer management function for Garrett Motion Technologies here in India. Thanks.
Ravindra, working in Bosch, heading engineering.
Hi, I'm Nick Townsend, and I'm responsible for the OEM sales across the EMEA and the APAC regions for Topcon Agriculture. We're a company who develop electronics for precision agriculture.
Thanks, Nick. Hey, good afternoon. My name is Vijay George, currently the MD for Newton India. Newton is new in India, just about a month old. Prior to this, I was with John Deere for about 13 years, leading the digital solutions group. Today, I will be representing John Deere, even though I've moved on. But I'll be talking about the John Deere technologies that we've been working on for the last digital.
That's the spirit of partnership.
Good afternoon, everyone. I'm Bhushan Sharma. I lead analytical research at CRISIL, where I take care of the automobile and agriculture sectors. Thank you.
Yeah, I think the context setting, I wanted to start in a different way earlier. Then just as our panel members, based on the minister's talk actually. For mechanization is important. At the same time, it's based on the minister's talk. I understand it is to be democratized, and particularly for the Indian small landholding farmers, affordable also. This is the way what I was talking is today we are moving towards TREM 5. That is one level of mechanization is initiated. Then towards, we have to go towards ISO bus of particularly the implements and all other things to be incurred with respect to that. So I think we will start with the TREM 5. I think Mr. Sanjeev is having his one presentation. We will start with that presentation, then we will go for the discussion is some kind of idea we are planning actually. Hope the panel members and others are okay. So let us start with Sanjeev actually.
So, good afternoon once again. Thank you, Session Chair, for this opportunity, and CII as well. You know what, I think my job has been actually reduced to a significant extent because excellent context setting since morning at Bharatendu and the minister and all the delegates. The way they have actually set the context, I don't think I have to spend a lot of time in that. But what I will be focusing today is on emission reduction technologies and fuel efficiency technologies for TREM 5. And this is in sync with, be it decarbonization or at least reducing the carbon footprint. There is also an element of being technology averse. Bhartendu brought that particular topic when there was a question from the audience in terms of, what are is TREM 5 going to, move on? I mean, will there be a delay? Can I have the presentation, please? Right, so I just want to give a little bit insights in terms of, how we can actually reduce this, apprehensions towards bringing in new technology because of the cost factor. Right? Cost is definitely an important element, and how we went about, addressing that particular cost factor. And I would like to table this over here because I don't think there is a better audience than this, right? While we are discussing about bringing new technologies, keeping cost in mind, from an Indian context point of view, I don't think there's a better audience for me to, actually present this. So there is a carbon footprint, there is a cost factor, right? And I'll give you a little bit insights on what the technology is and what we are doing about it. So, from a context setting point of view, I don't think I have to again do it, but some of the key points are, we are probably the only region in the world who will be manufacturing 1 million tractors, for the domestic consumption. The tractor industry is consistently growing by approximately 4% CAGR. And the implement industry, I don't have the numbers, but I'm sure, considering the low level of mechanization, approximately 40% today, and low level of productivity in comparison with the world, right? When I say productivity, the numbers what I have is approximately 2 tons per hectare, which is probably, half of what China is and the other regions of the world is. Considering that, there is probably a much growth, expected in the implement sector. But again, back to tractors, 1 million attractive market consistently. Those numbers we can see in the coming years, right? I spoke about mechanization, and again, this industry is predominantly, ruled by 30 to 50 HP tractors. I think we all know that. TREM 4 is above 50 HP, but TREM 5 when it comes, it's going to be for HPs below 50 as well. 40 to 50 HP is occupying 50% of that predominant share, right? So that's where we are. And imagine all these implements coming in, the functionality aspects of a tractor becoming expanded, right? What does that particular powertrain has to, the powertrain has to deliver much more at lower cost, right? Those are the aspects we are keeping in mind. So I've brought in some of the key buying factors over here. Price becomes the topmost priority because the end user does not really care whether it is TREM 4 or TREM 5. For them, it's price, the functionality aspects, fuel economy, right? These are the three areas which we were focusing on because we did a VOC. We went around in the field talking to the OEMs. I'll bring a flavor of that in my subsequent presentations, subsequent slides. So who are we? Garrett is a pioneer in technology. We focus on enabling vehicles become safer, more connected, efficient, and environment friendly. Most of our products will be focused on these three areas. Our core business as of today is turbocharging, which is engine boosting, and we have two emerging businesses. We call it as new growth vectors: electric and hybrid, traction motors, refrigerant cooling compressors, etc. And then there is a connected vehicle piece for which I have a slide towards the end, which is also relevant to India because we were talking about autonomous tractors and so on and so forth. 5 R&D centers globally, 1 in Bangalore, and we have 13 manufacturing sites and many software centers around the world. One of the important point over here is, we cater to the smallest of the smallest engine, 0.8 liter Tata. Now this year will be actually, serving a 0.7 liter Tata to a 100 liter Caterpillar truck, right? That's the range of, products we have. 99% of our technology, what we sold in 2022 came from emission reductions technologies. If you look at our flagship applications, I just want to give you a piece, a snapshot of, how we serve the off-highway market and specifically the tractor customers around the world. And there is a lot of presence here in India. We've been associated with John Deere for the last, I would say, 16 to 17 years. We are serving Mahindra nowadays, and we are making, inroads to other customers as well. TREM 4 is a disruption, right? We are moving from mechanical engines to electronic engines. Microprocessors are coming in, new technologies are coming in. 2023 January, it kicked in, and we are expecting TREM 5 also to get pushed. Tentatively, it is 2024, but we expect there will be some delay, as Bhartendu spoke to us today. Now, what does that mean in terms of technology? Right, new technologies in terms of powertrain are going to set in. We expect, common rail systems to come in on 50 HP and below as well. EGR technologies to come in, oxidation catalysts, DPFs, and there is a plus or minus symbol against turbocharging, and I'll come to that, right? It's an important piece of my presentation today. because, there are technologies which can, meet emission norms with turbocharging and without turbocharging. And the importance of turbocharging, I'll try to bring in that particular flavor because the efficiency part comes into play over there. Before I go into what those technologies are, let me give you a picture of what the customer out there wants. This is the customer VOC, right? The end customer, very simple. Low cost of acquisition and ownership. That is of the topmost importance, right? We cannot ignore that, we cannot discount that. Efficiency in terms of fuel, right? I don't think there is any sector in India which uses fuel, be it passenger vehicles or two-wheelers, tractors. I don't think tractors is actually any different from any other mobility solutions out there, right? Highly reliable and durable. Nobody wants to touch anything out there. Once it starts running, nobody wants to touch it, right? That is the third piece, right? Serviceability, no intervention. If there is an intervention, minimal, and preferably somewhere very close to the place that particular mobility solution is working, right? They don't want to go into service centers probably 15 kilometers away, right? So that could be one. And drivability. Drivability means in tractor terms, right? One of the examples I would like to take is when the tractor is moving in a particular direction, if there is a highland turning, they don't want to really let go of the accelerator, change the gears, right? Reduce the torque, lift the implement, turn around, then put back the implement, right? These kind of nuances they would like to avoid, right? But on the OEM side, right, the people who actually build the tractors, they would like to have, again, cost-effective solutions to meet emissions, right? Then reduced vehicle space, because you need to have a lot of visibility, hood visibility should be low. They want downsizing to be enabled, right? How they can make their engine smaller, right? Various duty cycles, because a tractor is used for multiple applications, right? I don't have to tell it out, but how the tractors are used everywhere and in multiple applications, and dealer services and training. So there are two paths for TREM 4 and TREM 5, the way we look at it. So one is, right, a turbocharged engine, EGR, DOC as a prime path for emissions, right? Be it TREM 4 or TREM 5, be it 50 HP and above or 50 HP and below. There is a problem with this. The problem is the perception of cost, which is true, right? And there is a risk averse towards new technology from an end user point of view, which is true considering that we are probably looking at it from a 10-year-old lens. And I would like to bring a novelty factor into this when I speak about it, and I'll come to this. The second way of doing it is naturally aspirated engines, don't change anything, slightly increase the displacement, don't add new parts into this. Yes, there is a BMEP level which will be compromised. There is a trade-off in terms of fuel efficiency because these are bigger engines, but meets the emissions at lesser cost, right? Now, is that sustainable? Because what we are trying to do is we are focusing on meeting emissions at lower cost, but we are not talking about the efficiency of the engines and the competitiveness, right? And I would like to bring a little bit more flavor into that, and we will discuss more during our technical session. So what we as turbocharger manufacturers thought is, from a functional requirement point of view, the way you look at it is, there are needs, then there are trends, and there are functional requirements. That's the way we are drilling it down. Low pressure ratio at rated speeds, we are talking about 1500 to 1600 speeds. So that is the speed at which the tractor actually works. Now we need to focus on that. Maximum torque at those levels, right? And one of the main apprehensions is oil throw. Everybody talks about, okay, there is smoke on the engine, there is oil. When you lift the hood, you see oil. People don't want to go turbocharging, but that is changing, right? And I'll talk about it. There are many OEMs who have tested it, and there are BS4 turbo tractors which are in the field. I think some of you will start benchmarking those tractors. Amazing technologies, no problem in terms of oil sealing, right? So those are all the asks, right? Needs and asks. I just want to kind of, on a lighter note, bring this particular analogy in front of you, which is called the engineer's dilemma, right? So you might have heard the Hiranyakashipu and Prahalad story, right? Hiranyakashipu does not want to be killed in the day or at the night from an animate object or an inanimate object inside the house, nor outside the house, on earth, nor in space, all these things. It's exactly what happens in our drawing room or in boardroom when we talk about tractors, right? Low cost, high performance. Right? I can see there is one person who agrees, right? compact yet durable. Standard product, but it has to go on a wide range. Low back pressure, it should drive EGR, right? That's for the powertrain people, right? Very low friction. Tamper-proof, it has to be tamper-proof. Nobody should touch it, but it has to be serviceable, right? So those are all the challenges which we, discuss in our drawing room, but there are other India-specific challenges. Before I go to solutions, I want to put this in front of you. No oil leakage, right? Low-end torque, high low-end torque, low RPM usages, TREM 4 and TREM 5 driving higher powertrain costs, and which basically means, there is a specific solutions which are required for these specific problems, keeping cost in mind. So what we're talking today is, we released something called the Garrett Tractor Series, and this is, in very simple words, it's just, it takes into account most of the problem statements and the needs what I just mentioned earlier. Some of them are, when you look at it from a cost point of view, it is one turbocharger size from 35 HP to 100 HP. Or let's say 75 HP, this is the range of tractors which we use in India. If we imagine a situation that for every 10 HP or 20 HP, I come and give a different turbocharger, right? The investment around it, the development cost around it, the calibration around it, all these things make our OEM partners fret. They say, sorry, right? Let us stick to this high, displacement, solutions for meeting emissions, right? So what we said is, we have to help them over there. It's a valid ask, and we have to help them over there. We came up with this particular solution called one frame size, which serves 25 HP to 75 HP, right? One solution solved. Then there are other, some of the patented oil sealing solutions which we are using, right? I will not go into the details because, I have a slide on a white paper which we are releasing today, and you can actually, I'll come to that particular slide. But, it is not just about product alone, right? I can make the product as robust as possible. It is one of the smallest turbocharger, takes care of transient responses, which I mentioned about the torque issues in the low end, EGR drivability, oil sealing, one product fits for all these things are the product side. But it's not just the product alone. There is something beyond the product, and we call it as the four-pronged approach. How do we make sure that if there is a problem in the field, within 12 hours, how does this particular person change the product, right? Not waiting, because, every hour wasted in the tractor is basically, the revenue lost to somebody else, right? So from that point of view, how do we make sure that it happens? But there is also another problem. People don't want to change the entire system. If a turbocharger breaks down, right, they don't want to change the turbocharger. They want to change the part which has broken down, right? So service kits. And how do we educate those end users, right? How do we expand our service networks, right? All these things are a part of the tractor series, and I will just leave it over here, but the reason I'm leaving it over here is because I also want to make you curious to read our white paper which we are releasing today, which kind of details all these solutions. So that's basically tractor series for you, not just the product, but beyond the product. So some of the differentiators, some of the technology which has gone into it, I would really encourage the OEMs to look into it. It is there in the white paper, free for you, but that should give you more confidence in terms of what kind of technology is going at lower cost, so that we can actually address all the problems which our farmer friends are facing. Okay, so there are some patented sealing solutions, etc., which we can go through. Right, this is the white paper we are releasing today. There are standees outside this particular hall. You can take the QR code, go to this particular white paper, which gives you the trade-off between a naturally aspirated solution versus a turbocharged solution. Right? Why we can actually turbocharge tractors. Some of the OEMs are actually doing it on TREM 5. As I speak, on the drawing board, turbocharging, downsized engines, knocking off one cylinder, making it 3 cylinders, right? Perform as good as a 4-cylinder, but at lower cost, right? That's basically the trick of the trade. So please, take the opportunity to, download that particular white paper. And my final slide before I conclude, maybe the last but one slide is connected vehicles. We also have, and this is becoming very relevant, and we'll speak in the panel today. There are a couple of solutions which I want to put it in front of you, and we can discuss it offline as well. One is called advanced control. The second one is called prognostic and diagnostics. Let me focus on guided diagnostics, for example, right? And I think my industry colleagues also have similar products in the range. The solution over here is when a tractor or a passenger vehicle, end user goes into a service bay because there is a problem, how the service bay technician can get to the problem quickly without iterating. Trial and error is reduced. There are error codes which are fed into the system upfront, and there is an intelligent system which actually involves machine learning, which points out, okay, there is a problem in your tractor. Let's take, for example, this particular powertrain. Looks like there could be 5 potential reasons for this. If you attack number 1 in the top of the list, there are 95% chances that your problem will be mitigated. Then there are 5% chances it may not be. So for that particular 5% chance that it is not mitigated, the second area where you have to focus is this. That kind of an intelligent system is what we are talking about. It's called guided diagnostics and prognostics, right? So we will discuss more about this offline, or if you have an opportunity, but those are the offerings which I wanted to place in front of you, because that is what is relevant for India in terms of productivity, in terms of carbon footprint reduction, in terms of cost conscious, customers. With that, I will end my presentation by saying that, it's an exciting time for the industry, growth potentials both in tractors as well as implement industry. We have a lot of experience in turbocharging tractors in India for more than 15 years. We've been bringing a lot of experience from an India for India concept point of view, right? And there is a lot of software play in the future which is going to improve the productivity, and we can help you over there. With that, I'll close my presentation, and thank you for your attention. Thank you.
Thank you, Sanjeev. It's really a good presentation. The thought progress is, one is this particularly the engine to prognostic and diagnostic you have initiated. For that, before that, what I'm thinking is the connected solutions are important for, particularly on the tractor side actually. Particularly the internet is a typical example of how the military to common man has a democratization. The connected tractors, particularly the connected solutions bringing into tractor is very important. If you bring into that, naturally, for example, Mahindra has introduced the DigiSense as a product. So it is having the acre meter, geofencing to fuel levels, various advancements are there. But it is really utilized in a very great way as a platform. So the connected solutions are very important. Then that will lead to the proper mechanization also. When the mechanization is happening properly, then the precision will naturally come. Particularly the connected solutions, a lot of the tools are there, including which helps farmers for, particularly on the humidities, how to plow, all these exercises connected will give. Also the connected will bring into bigger data science actually. That will give a big market for our data analytics, which will talk about even for the engine failures or engine failure effectiveness, and before taking the corrective action, and also improving the yield, and also improving the crop productivity. So that is all very important. Also the serviceability also will lead into effective connectivity. So the fundamental is, one of the things is I'm thinking of the IoT enablement actually. And second one is how the kind of sensors and actuators affordable. And third one is we are moving towards naturally as I talk about the engine ECUs. From engine ECUs to the common body control modules to the effective implements are now coming with ISO bus. That will give more productive implements will come actually. So then naturally the EV and hybrid and also the autonomous. So I think now this, particularly since we talk about Trump 5, I'll give the forum to Mr. Ravindra, who is working in Bosch as an engine advanced technologies. I think he can throw some lights on our path.
Thank you, Mr. Shivakumar. I think I would not go back and talk about the context setting because it's well done from morning. But I would like to take it from where Mr. Tiwari left. If you look at the theme today for productivity improvement and sustainability and things like that, we should start from tractor. So what we have done is we have transformed now from mechanical to electronics, at least a certain segment. In TREM 5, many portion will go. And if you look at have we completed everything? No, we have just started. So if you start from tractor and then comes the implements and then of course the connected solution and things like that. So if I now look at tractor itself, there's a lot to do. Also, Sajeev explained about efficiency improvement in tractors. That's going to be one of the major tasks, also reducing fuel economy, which will contribute, of course, directly or indirectly to productivity. So now, also from tractor perspective, if you look, since we are right now already electrified, so it's very easy now to adapt all the topics or solutions what we already have on-road vehicles. For example, we are working in Bosch from past couple of years on how do we now take the advantage of electrified tractors, also give solution which increases the uptime or the turnaround time. We have been working in a couple of solutions, which is, of course, in the constant stage now. And for example, if I look at the injector drift, there is a problem in the injector, and we can much ahead sense this, and we can also bring it to service, or we can bring it to service station whenever there is a free time. So this is one which we have already proof of concept is available, so we'll bring it to the market as well, which will of course help the tractor manufacturer or the end user as well. And the second one, what we're working is also from the fault code identification, like what Sajeev mentioned. This is already implemented now. This is also a concept where you will be able to identify where the problem is much faster, and it'll have save a lot of time. And it can either be to the end user on the app based, or it can also be the service station, where the service station will have the database, and you can always contact the end user to say that if there is a problem. Of course, this is much better used when it is cloud-based, not the edge-based system. We are also working on the cloud-based, where the data will be available on cloud, and this can be read by either the service station, if possible, also by the app. So these are some of the things what we would need to do if in the future, and these are also some of the topics which are kind of necessary and affordable to start with. And then if you look furthermore, and if we also next come from tractor to implements, of course, we can also make digitalization connected implements, and then use that to also serve productivity in a big way. And if you look at what's happening worldwide, so worldwide, they're already advanced in looking at topics of IoT, artificial intelligence, and things like that. But that is not possible in India if we are not connected, if we are not coming together. What I mean coming together is, if you look at worldwide, the arable land, we already know it's pretty big. And in India, we have very small, so 1 or 2 acre. And if we look at the farmers, affordability of farmers for such technology, it's pretty bad. I don't think anybody can afford this across India. So now, what should be done? Because the technology is available, the technology can be taken over, but how do we now bring to India? That is what we need to think about. And if we want to bring this, and if you want to make it affordable, it is not possible that we work only with the farmers with the arable land on the higher side, but also we should think of the farmers who are working with very low. These are the things what we need to, but the technology is available. There are a lot of development happening in Europe on IoT-based or AI-based, and where the productivity is increased. There is example, fertilizer utilization with IoT and AI-based, they have proven 70% reduction in fertilizer use. So these are already available. This can be brought in India, but the topic is it should be affordable. It should also be somehow applicable to the Indian farmers with low arable land. So this is where I will stop my topic, and then I will give chance to other colleagues as well, that I will come back again.
Yeah, exactly.
Thank you.
I think now, as he told, the affordability with respect to these small landholding farmers, particularly I think if you take about John Deere, it's a work-wise, large landholding farmers, a lot of technologies they introduced. But they are also available in India, and they are also doing well. So in this way, I'm giving this forum to Mr. George. Thank you for representing John Deere, and please explain about what is your views about how the small landholding technology is affordable with respect to Indian context.
Sure. Thanks for the opportunity. Again, before coming to India, I would at least set context of what John Deere has been doing globally. And then there's active work going on how do we bring some of those technologies back into India. Now, Deere has been investing in some of these Precision Ag technologies for over 2.5 decades. Even before anybody started talking about GPS, which has become common language today, Back in the 90s, Deere invested in GPS technologies and has been working on that, and all of that is paying off today, where technology has become the core pillar of the strategy for John Deere. And they've been working actively on this. So just to set some context, and again, I know some of this has been repeated earlier, but mentioned earlier. An average farm in the US goes into thousands of acres, right? If you look at an individual farmer, he'll be managing anywhere between 3,000 to 5,000 acre farm. Not necessarily all together, they may be split into a few individual farms, but individual farms would be anywhere between 200 to 700 acres. Now, a farmer manages that along with 2 or 3 individual help, mostly family members, and maybe during peak season, he hires individuals to run his equipment. How do you enable him to run his business effectively? Run 700 acres or 2,000 acres and be productive, ensure that the yields keep getting better every year. And that's where technology comes into play, right? Now, if you look at Deere machines globally today, at least when I was leading the technology piece out there, we used to refer to them as nodes on the network, right? We've all heard of that terminology in the IT world. When you work in organizations, your laptop is a node in the network. For me, tractor is a node in the network. Sitting in India, I could remotely diagnose any tractor globally. I didn't have to be physically present. If there is anything going wrong, I could sit in India and remotely diagnose any machine globally. That was the capability which existed. These 1,000-acre machines, these 1,000-acre farms, today we have the capability to tell the farmer every square inch on that 1,000-acre farm what has happened, right? Every square inch, which seed went in, which seed variety, what distance was it planted, what depth was it planted, what was the yield, what was sprayed, how many times was it sprayed, not only for the current season, but I could go back almost 10 years and tell them how the land has performed, what seed varieties have given what yield. Based on that information, the farmer is able to make better decisions along with the agronomist or advisors that he works with. They're able to make better decisions. That's the power of technology which you hand in back to the farmers, right? And it's pretty advanced in terms of the maturity of how farmers out there farm. The seed spacing, right? The depth at which seeds have to be planted. All of that is automated. You could write a prescription and say, hey, this seed needs to be left on the ground or 2 inches or 5 inches. The machine will automatically implement that. It doesn't have to be manually managed. The machine automatically does that. And that's the power of data. We have been collecting data for over a decade and a half. Data is powerful. We keep hearing that across industries. For Deere, data is extremely powerful and something that we've been focused on for the last decade and a half. There's a saying, pretty strong saying, which said that data is not an exhaust which comes out at the end of a process, right? You're not looking at data which is you get at the end of a process, but it's a fuel which is going to drive your subsequent operations. So think about a crop cycle. If I can get data of how my planting has happened, and if I can use that planting data to do my spraying operations in a better manner in the same season, or use my spraying information to do my harvest better and get a better yield, that's how you're helping your farmers to get better at their operations year in and year out. And that's all happening real time today. Intention is we will bring at some point in time, John Deere will bring this to India at some point in time. It's not easy. The scales are different, the constraints are different, the maturity is different, but there is a roadmap of how all of this will happen. Couple of other aspects. We've spoken about sustainability, right? Sustainability is going to become big. Every industry is talking about it. It's going to become a major talking point for agriculture also, and Deere has been working on that. One of the technologies which got spoken in the last couple of years is See and Spray. This is primarily around spraying, right? About the fertilizers you're spraying on the seeds, on the plant, as well as fertilizers which seep into the ground, which is becoming a bigger concern across the globe. How do you reduce that? So there's a See and Spray technology where a sprayer is running at about 16 miles, 18 miles an hour. It has a 120-foot boom with about 36 spray nozzles, each individually controlled, and about cameras which do real-time tracking. And when the tractor is going at the 16 to 18 miles, it's able to take an image and analyze that the green thing that I see on the ground, whether it's a plant or a weed. And only if it identifies it as a weed would I spray chemical on it. If it's a plant, I do not spray chemical on it. That is reducing chemical spraying on the field by almost 80 to 90%. There's not only spray chemicals going down, but also the cost associated with that. That's a huge progress being made on the sustainability aspect. And there's many more technologies which are coming along in the journey with that. We spoke about customer uptime, right? Some of these applications are very, very time critical. You talk about planting. There's about a 7 or 8 day window which a farmer has to get his seeds in the ground to get an optimal yield. And if he misses that window, your end yield is going to get impacted. So how do you ensure that the machine is available up during those operations? And during that 7 to 8 days, these machines are running 24/7. Remember, I spoke about 2,000, 7,000 acre field, and the farmer has to complete that planting operation within that 5 to 7 days, right? Machine has to be available, cannot have a breakdown. And we have had solutions or services where we offer something called an expert alert. Based on the data that we have collected over the decades, we today can predict your machine going down before it fails. So there are patterns which are identified saying, hey, if this is the pattern that we have seen in the data coming in, I know this particular part is going to fail in the next week or next 10 days. Based on that, we are able to tell the customer as well as our dealer to stay ready with the part and ensure that the machine is taken care of before it gets impacted during the season. So these are some of the examples where we have been using technologies. It's pretty cutting edge. A lot of people outside the industry do not realize the amount of technology which goes into agriculture. Some of these are active collaboration with folks like NASA, right? John Deere works actively with NASA on some of the GPS technologies. Autonomous is another one which Deere has been working extremely closely with, and there are in-production solutions which have been released in markets like US. We'll get into some of the more specific examples as we get into the panel, but with that I'll hand it back to you, Shiv.
Thank you. As he told, actually, the very interesting thing he told is particularly the depth and draft. Particularly the electrohydraulics is leading into that show. That definitely, with respect to that, the control systems will be easier. Definitely, farmers' productivity will improve, actually. Also, the precision, when it is been properly connected through the GPS or GPRS system, then the farmers, how much depth he is having it, he can see it in the dashboard also. So with respect to that, he talked about the spraying, particularly the spraying. One interesting thing is John Deere and various people are working on this, particularly on the spraying. The spraying, the autonomous way also it is happening, but the challenge is for how the cameras cost-wise affordable for the Indian ways of how it has to be. That's very high resolution cameras required based on that crop, insect and other things, how that's the difficulty of it. We can spray it at that particular location itself. So GPS technology and also the controlled engineering and also the spraying technology will help for that actually. But slowly when it is going towards automation and autonomous, I think it is right, Mr. Nick talk about it actually.
Thank you, Siva. And yes, just to introduce Topcon, we're a Japanese company, but we've been in India now for over 30 years. Obviously, I appreciate both affordability has been discussed a lot today, and possibly not always the first kind of thing we'd think of. But what we're also focusing on is still keeping affordability, but actually looking at value. What value the farmer gets from that investment, and what that ROI then looks like, both short-term and longer-term. But as again, word we'll hear a lot today around sustainability. So ultimately looking at this from both the environmental and the farm perspective. So introducing precision ag. The numbers that get bounded around, somewhere between 5 to 20% yield increase. However, that isn't the sole kind of thing we can use to double the farm's income. We also need to look at that yield increase, but also the inputs that go into that. So how we can save fuel, how we can save time, how we can use less inputs. And as my colleague here said, kind of the environment. So where we put that fertilizer, how we use less of it. And that's ultimately where Topcon come from a full cycle of farming. So looking at the initial land preparation, how we do that land leveling, and then to the seeding, again, what depth that seed is put at, what population we use. It may be that for poorer areas of the field, we actually don't put as much seed in because the growth doesn't give us the actual yield increase. So there's no point in spending kind of good money after bad. But then again, moving to the fertilizer, either a pre-planned variable rate map or using AI and see and spray and actually assessing at the time what that field and area needs. But then we also need to prove at the end of the day the decisions that we've made all throughout the season are actually causing an effect, whether positive or negative. It may be that decisions that were made throughout the year have actually caused a negative impact on the yield, and we need to understand why that is. So we also produce solutions, yield monitors, to actually weigh the product that comes off the field, both weighing on the trolleys so that we know a very accurate total weight, but also a yield monitor for variation across the field. We can ultimately call that yield map a kind of money map or a profit map. Where within this field have we made profit? Where have we potentially lost money because our returns haven't been as good? And then use that data to make sound decisions for the next year. Now, this is where the AI modeling and the years of data come in that it may be if you make that same decision 2 years on the row with the same kind of conditions, we get a very different result. But then we can delve into those models and see slight weather changes, external factors that have then caused that difference. So I think ultimately what our kind of focus is on is A, generating value, but B, making the technology accessible. So we've taken, within Topcon, we've got acquisitions that were originally at the forefront of precision ag. So coming from kind of 1969, grain loss, yield monitoring, auto steering, but then taking that kind of global knowledge and that global solution, extracting the IP and the solutions and the software, but packaging it up in a new way that is also both more affordable, but also less scary. Rather than putting 100 features into a box, let's start with putting 5 in, and then maybe build that up. And initially with the kind of the 1% of the market, the leaders, and then filtering that technology down so that it becomes accessible for all. And ultimately, as we move to kind of agriculture 4.0, move to autonomy, retaining and ensuring that as an industry, because it is all of us together, not just one, that we demonstrate to the market where that value comes from. And that also comes from us as an industry all working together. A piece of electronics on its own is no use without a hydraulic system or a tractor or an implement. And it's about everyone kind of working together to create that market, to create the value and the sustainability for the future.
Ultimately, it is finally for the crop and crop cultivations and crop dynamics. In this way, I will request Mr. Sharma to speak about it and his views about the crop dynamics and other things.
Thank you, Mr. Subkumar. So as a passionate observer and researcher of the industry, I'll talk about it from an outside-in perspective. Mr. Ravindra spoke about low land holding and thereby poor affordability. So yield is, one critical aspect that we need to focus on. But along with yield, we also need to shift our farmers towards remunerative crops. Now, if we look at India and China, from an agriculture perspective, these are comparable countries because while India's average land holding is about 1 hectare, China's is only 0.6 hectares. We have 15 crore households or land holdings. China has about 20 crore land holdings. If we look at the arable land, the agriculture land in India, we're about 140 million hectares in net sown area. China is about 120 million hectares. But now the interesting part is with only 80% of the agriculture land, the production that happens in China is twice as compared to India. in terms of volume, and in terms of value, it's actually 3 times. So not only are they producing more from the same land, but they are producing more remunerative crops, which then links to the aspect on affordability, that with all of these smart tools and technologies, how do we make it affordable? If we look at paddy and wheat, some of the key crops that are sown in India, China's productivity for those crops is 70 to 80% higher. We are almost there at the world average, to be fair to India, when we talk about paddy and wheat, but China is about 80% higher. And which is where the agri-input industry will play a very critical role. And what I wanted to highlight further is that there is a lot of headroom for the agriculture input industry in India. If you look at pesticide consumption, we're about 0.3 kilograms per hectare. The world average is 2.6 kilograms per hectare. We're at about 38th position when it comes to the fertilizer consumption per hectare. If we look at US, an unfair comparison definitely, the average land holding, like my colleague pointed out, there is about 180 hectares. They have more than twice the land, arable land, as compared to India. But what's interesting here, and why I'm sharing this data, is they engage only 2.5% of their population in agriculture, compared to about 50% of our population. So the labor intensity is also quite low in US. And all of these, what these data points suggest to us, is the headroom that the agri-input industry has in India in the coming years. And what I would like to conclude by saying is that if you look at the structure of the land cropping pattern in India, 85% of our land holding is on the low income crop categories, that is the field crops. Only 15% of the land is engaged in horticulture. What we need to do is to reduce the land that is engaged in field crops and get our farmers to shift towards the horticulture crops, like what China has been able to do. And that can only happen if we are able to increase the yield from lesser amount of area if we still produce the same amount of crops that we are producing today. And which is where technologies on the smart farming, farm machinery, use of sensors, IoT, that will become more affordable for the farmers in India. And lastly, the business model also needs to evolve in India. The medium and large farmers, which constitute only about 14 to 15% of farmers in India, they might be able to purchase these tools and technologies on a standalone basis. A large majority of our farmers, if we really need to scale and we want to see the volumes, we need to cater to the 86% of the farmers who are holding much below the 1 hectare of average land. And that's where the business models need to evolve as to how we can serve this large population of farmers with these evolving tools and technologies. And with that, I'll hand it back to Mr. Sivakumar.
Thank you very much. So the major things are actually, one is that small things. For example, he talked about that electrohydraulics will give the ease of controls. And simple controls like head landing and also the one-side braking kind of a small things, which will definitely improve the farmer's productivity during his when he is doing the field process actually. So I'm just almost, we are talking about the existing technologies and what is the feasibility. I'd like to give this forum to the next level of technology, which is going to, because particularly our Indian government is pushing about electrification. So when it is particularly today, electrification in auto is very critical actually. Government is really pushing it, but a lot of subsidies are given. But here, if you are asking about the electrification in agriculture field, what I am thinking is definitely farmers definitely will get electricity free. Unlike tomorrow, what will change for automotive, we don't know. When the subsidy is reduced, what is? But with respect to the farmers, electric is free actually. And also particularly the electric motors or the low-end high torque motors. The farming machine is a torque machine basically. And particularly the permanent synchronous motors are giving at low RPM very high torque, particularly 6,000, 6,500, which is majorly the tractor is running in that particular speed actually. So I would like to give this forum to talk about it more about what is the feasibility of electrification in tractors. Who can start actually? Maybe Nick, you can start about it.
Yeah, certainly from our perspective, in a lot of what we look at from the implement control has been around improving fuel efficiency So as we discussed, depth, but yeah, as we move kind of towards EV, looking at still those models and how we can still reduce that battery usage rather than the fuel. But yeah, from our perspective, it's about generating field data that can then be fed into those systems to understand how to get more efficiency.
Any other thought? Any?
While I agree that electrification would be advantage in several areas, but I don't think it can go beyond certain use cases. The main reason being, if you look at the power consumption, 8 hours per day, or if you're working 24 hours per day, so if you want to keep this energy level continuous flowing, and that's the biggest challenge what we have in electrification. So I would say there are certain use cases where electrification will come, but certain use cases will, of course, depend on fossil fuel, diesel, basically. Of course, upgrading to hydrogen in the future may be also supporting the vision of government. But I think the electrification will be limited use cases from my perspective.
When it comes to electrification, there are two kinds. One is, battery electric, let's say. That's pure form of electrification. Then there is a intermediate, which is the hybrid. And we are so cost sensitive, right? Hybrid at this point in time doesn't make real sense because you have an ICE technology. On top of that, you have a battery technology, right? Which has to drive. It makes a lot of sense in passenger vehicles, but these are all high torque applications. So I would discount hybrid at this point in time from an economics point of view. When it comes to battery electric vehicles, I agree to Ravi when he says that there are certain use cases, and in India it becomes more of a challenge because tractor, again, as I mentioned, is not just used for one purpose. You take a tractor, I think the way we exploit tractors is we use it for multiple purposes, and that is where the duty cycle becomes a challenge, and the electric machines addressing those duty cycles, right? Be it haulage, be it plowing, be it hauling waters or whatever may be it, making these electric machines compatible to multiple duty cycles become a challenge. One of the good cases for electric machines is orchard farming. That's what we see in
orchard
other
farming.
countries.
Also nowadays, the small thing, urban farming is improving in a thing,
Hobby
which is
farm.
almost like a USA kind of things, which we are coming into that kind of a.
Correct.
thing.
I think we can anticipate or envisage those days or in the years to come where probably a particular machine will be used for a particular purpose, right? And in that kind of an environment, in that kind of a situation, we can probably think of an electric machine because you can anticipate more how much you can actually take out of that particular electric machine. At this point in time, battery electric vehicles, specifically in off-highway tractors, very, very specific segments like orchard farming, hobby farming, etc., which is what is prevailing in the US, but in India, if it picks up, it can happen. But until then, I would like to reserve my expectation from that market.
Yeah, one more thing is the parallel thing which is going is on electrification, particularly as I told, the battery is a lot of limitations are there in terms of duty cycle and also the longevity of the battery and the end of life. Various problems with respect to lithium and we are going to face. Another thing is parallelly growing is particularly the hydrogen engine. Well, Mr. Ravi, why don't you talk about it more about it?
Yeah. So like I said, so hydrogen can be a game changer. And if you look at all the vision of our government as crude oil import reduction to air quality improvement, and also with respect to carbon neutrality. So hydrogen can address all this topic. But right now, it's the technology is under development. It's not only in India, and I'm really happy to say that we are front runner in hydrogen. Also in series project, what we are working on compared to any other country. So right now, what we are in the learning stage. We are looking at commercial vehicle as a segment for the first introduction. Also not in PASCA. Mainly PASCA electrification is already proven. that the use case is best fit for electrification. So in commercial vehicle segment, we do not have an alternate right now, apart from alternate fuel, of course. We need something to help also the government vision. That's where hydrogen will help. If I look at tractor segment, now I'm in off-highway segment, it's a little bit far from my perspective, mainly coming from the reason we have not still experienced CNG, the gas engine so far. And second, also the availability of fuel at the place where you need. That's going to be a biggest challenge. Of course, you can see JCB bringing in dispensing station to the place where you need. But of course, this is one such scenario where it can help. But if you want it to across India, across farmers, if you want to bring this, that's going to be a challenge. What I see is there is much to do in diesel, also in off-highway segment. And later, once we have transformation in CV towards hydrogen, and there will be a lot of learning on that, and frame safety aspect, of course. And then once we learn, and then also bringing this technology to off-highway is good enough, I would say. So it's a long-term solution for practical perspective.
Yeah, actually the electrification and another one is the autonomous. Particularly the autonomous with respect to one is this diesel to autonomous or electric to autonomous. So what is your thought, Mr. Nick, about it?
Yeah, and as we said, kind of what we're seeing within autonomy is also gradual steps. So irrespective of engine technology, how we get there and put in place the building blocks. Now that could be from initially path planning and mission control versus then actually perception and self-awareness and how it makes those changes. But again, yeah, from an engine perspective, working with what we've got, but also bringing in the implement to that. Having an autonomous tractor that follows a plan is one thing, but then also having the technology on the implement to tell that tractor what it's now expecting. If that's a change in forward speed due to spray quality, then suggesting that and adding that into the mix.
It is bringing into the autonomous or other things. How John Deere is the thinking and what is the view your thought of it actually?
Sure, it's quite similar to what Nick mentioned, right? There's a lot of work going on, and the technology is getting proven in different use cases. But John Deere did introduce one of the first.
Yeah, because when the TREM 5 is coming, a lot of ECUs and other things started introduction.
Sure.
So as architecture is scalable, a lot of sensors already started coming.
Sure. And again, I'll restrict my view currently to the US or Western markets because India is still some time away from all of this. But Deere did introduce an autonomous tillage machine out here. But as Nick mentioned, it's not about having a tractor go autonomously from point A to point B, right? End of the day, the farmer is getting a job done, whether it's tilling, whether it's planting, spraying, harvesting, there's a job being done, and that job is an extremely complex job. And how do you automate those activities, planting, spraying, harvesting? That is extremely critical, and that's where things like path planning, perception engineering, all of that comes into picture, and there's a lot of work going on there. You will see more and more machines getting introduced by John Deere. The first one, as I said, has gone commercial, is around tillage, and you'll see subsequent operations also getting out there.
The one thing is very interesting, I can ask this forum is, particularly the engine, particularly the electronics, various things are introduced. So the implements also has to be knowledgeable and other things, and it has to be, because that is why the ISO bus, the worldwide is coming actually. But ISO bus, we have slightly far away from that actually. But how the implements kind of things, the ease of controls or yield improvement, what kind of things we can do?
That's the biggest space for India to improve.
Explore.
Again, I think it got referred earlier today also. There's a lot of work which has happened on the tractor side, but huge amount of opportunities on the implement side, right? Implements have to start becoming smarter. There's a lot of opportunity there. We see that
Mahindra launched the Tezi as a model, the smart rotavator, which is giving you good yield also. I think it is a so implement side also there is a good possibility of introducing technology into the tractor.
Without implements, you're not going to see
major
improvements.
Final output will not come actually. That
implements
is very important,
are the biggest opportunity beyond tractor of introducing technology.
Yeah, I think almost 1:30. What is any other thought progress for panel members? Or any audience will ask questions? Yeah.
Hello. Yeah, I'm Prasad from SAP Parts. I have one question. I've seen a lot of tractors having the hub tracks in the other countries compared to India. And when you can see, particularly for the construction sites and river beds, the hub tractors are always have the advantage of more traction. But why we are not being able to introduce the hub tracks, efficient hub tracks in India? That is my question.
Can you, okay, what's the exact question actually?
I'm talking about the wheel tractor versus hub track tractors.
Okay.
Track tractors. Yeah, track tractors, which are more powerful for the torque point of view. And if you see the river beds and the constructions, they can be
which is
used,
used in abroad and
moving out the excavators out of the river beds. There are a lot of uses, and you can control the width of the tracks, and that can give more traction. So
I
along
think
with
it is
agriculture.
feasible only, I think, but that kind of things make me explode actually.
Yeah. So does anyone have the idea?
Anybody can throw in the forum?
Okay.
Cost is the major. How it is affordable is the.
You'll be able to operate. So they have got a particular use case what we are discussing. Track is good. That is why mini excavators are all with tracks. So small space turning radius, track will give better advantage.
Yeah.
So we don't have in agriculture as of today. One is costly. So
Okay.
we cannot use, even though it has got a smaller radius, we cannot use it.
Okay. Yeah. Thank you.
So good.
So with tractors, if we have tires, the mobility is much more better. So customer has to move from his home to the farms. Now expect if you have tracks, you can't take it onto the roads. So
Yeah.
that again becomes a
No.
problem.
They are using
Yeah.
track with the combine harvester.
Yes.
Yes. Yes. Yeah.
But that actually then is mounted on trucks, and then it goes to the area wherein the tracks are required.
But a lot of tracks coming on the road, running at the 40 meters per second, 40 meters per kilometers per hour tracks are available, and different widths tracks are available. So this is something. Yeah. Yeah, rubberized tracks. Yeah.
Only for South India. Means wetland
Yeah.
harvesting, we are using it.
Okay.
Tractor, water wheels are available at the cheaper cost.
Okay. Thank you.
Obviously, we will go for
It's affordability is the issue. That's what the.
Thank you.
It. Any other questions?
Yeah. So one question, I'm not very sure whether you will be able to articulate it from answer point of view. See, we've talked about the alternate technology which is coming in. You talked about electric, you talked about autonomous, a whole lot of technology which is coming in with respect to upgradation of the norms of the tractors, right? Now, if I look at gelling this with the research that happens in the agri universities, there is a wide gap because our curriculum in the universities still continues to be what it used to be 15 years, 20 years back. So the raw material which is coming in, how do we bring them quickly up to the speed so that the execution part in the field, adaptation in the field becomes much more easier. So any thought around that? How do we change?
Okay, I will talk about from my experience, particularly the electronics. India is one of the best country for electronics, but the electronics cost is high for that. So in this way, if you are asking the working with universities,
My question is not with respect to electronics.
Okay.
See, the agri application, when it comes to execution in the field, it is with respect to farmer, right? Now, electronics, yes, we have a raw material available and we are very advanced, but they are not able to connect to the agri applications.
That's what I'm saying.
Right?
So that's
So,
what the
I'm
integration of
yeah.
set. For example, I did one small thing. I will give you an example in my experience. I linked Punjab University and IIT Chennai. IIT Madras, we are working with some electronics project. When we were working with the Punjab University, particularly, Suraj is also part of Mahindra. So then there is a conflict has come actually. Then I told the Mr. Professor Sivandesan to integrate that also. Then finally we came with the product called a Smart Rotavator, which is a patented product now, I think giving the good results in the Tesi also. So like that, we have to work with more universities as an integrated way. For example, today there is a multiple integrations possibilities are available. And for example, Virginia Tech, they are working on the robotics and other things actually. But in same way, robotics for industrial application, IIT Trivandrum is working. But the same thing, somebody has to throw the challenge toward them, because today the tractor is the one machine. Tomorrow, a robot can be replace the tractor also. We don't know. I'm talking about next 25 years actually. So a machine itself the look itself will get changed. What is we are tracking last 50 years. So that kind of thing we have to explore as integrated universities. Maybe industry and institution, more link will come actually. Hope I answered, I think.
Yeah, that's one area where I see
we have to improve a lot. Yeah.
I just want to comment. I think I agree, right? It's probably not just agriculture, but it could be probably multiple areas where there is a disconnect between the industry and the academia. Specifically when it comes to textbooks or the curriculum, there is definitely a disconnect. I think more often the industry goes and does a project with the academia on a need basis, but that does not actually flow back to our curriculum. Right? For example, there is a problem in the field, or there is a need out there in the agri sector, right? And if an industry finds an opportunity, we normally go to the academia, we start a project or put on an infra, do a CSR, right? But then there is definitely a gap in terms of how this particular need for the technology flows back into the curriculum. I think there has to be a concerted effort. I'm not sure. Honestly, I don't know.
I do agree, sir. But what I'm saying is, particularly, I was there in the Aachen University. Aachen University, when they are working with the industrial projects, 50%, and they create the indigenous thing also. For example, I saw that they made a three-wheeler tractor and running. The professor is testing about the reliability of that question when the Viva has come. But in India, people thinking about as a POC concept, our people are sanctioning the projects actually. So that kind of definitely we need a lot of improvement between the industry and the institution. A lot of improvements are required. I agree that.
I too agree, because it's not only in tractor segment, in any segment we have this issue. In Germany, if you see, there is government-funded projects. It's coming from long time. And these government-funded projects are basically driven by university, industry, and government. So all together, they drive this. And if you also look at the infrastructure at the institute, is far, far better than industry as well. Sometimes it's much better. Yeah. And when institute has got really an infrastructure where they can go deep dive into technical aspects, and that's where industry can collaborate and do more. And right now in India, what's happening is industry is trying to collaborate with institute, but they're not getting anything out of it, not in a big way. So that means there should be some effort between government and institute as well as industry to see that this works together. And that's one big gap, of course.
Some of the companies are doing that. They are going to the industry institutions and sponsoring the students from the third semester onwards. And completely they are integrating a lot of research projects. They are doing it, particularly in the two-wheeler side. It's happening some four-wheelers, but it has to happen in tractor side also. Particularly, because we have to bring the. For example, if you take, I study the syllabus of Coimbatore agriculture there is nothing about technology at all. Only the machines and other things. They have to rechange the syllabus according to the IoT means the students will know from the outside only. Like that, they have to change the syllabus also.
Mr. Nick, I have a point to understand about the autonomous.
Sure.
Just as India context, if I see our plot size, farmland plot where we do the farming, we struggle to get a farm size of 60 meter by 40 meter normally in the field. Autonomous, how we understand as on date, is first making the straight pass and then taking us a decision to take a right turn at what place. So you can minimize number of passes and optimize maximum productivity by reducing the turning and all time. But how we see this plot size accommodating to the autonomous system what we are working today? Because normally my tractor length comes to the approximate 5 meter with implement. I have another 20 meter to run
Yep.
and take the turn. So how all these things are, but this will be a big challenge to you. How you are accommodating this?
No, for sure. And as you say, depending on kind of implement width and turning circle today, sometimes there is skip pass. We're looking at some alternative ways of also taking the next bout in that today the conventional is kind of a U-turn or a keyhole, but also possibly looking at K or Y turns, where because we've got transmission and speed control as well, you can do a kind of 3-point turn, including reversing to that as well. So then more utilizing that kind of minimal headland, but actually utilizing more area of the field. As I think someone mentioned earlier, it may only be that 70% of the land holding is actually being utilized. We're sat here today saying we need to get more out of the available land. So the closer we can get to that boundary, the more ultimate kind of land growing proposition we have.
I have a point for Ravindra also. Ravindra, we are talking about the means to propel the vehicle, electric, CBG, all these things. Now there's again a discussion about self-fuel. Self-fuel, that means farmer can produce the ethanol and use the fuel. Are we working on that direction?
Interesting question.
See, of course, we are working on CBG. CBG is also where I think IOC has set up a facility in Panipat about using your paddy waste, which is the big problem for NCR, and making ethanol from it. And now IOC is standing with the surplus ethanol. So they are talking about mixing with the diesel. So is that a time we will be ready with the engine itself, which will run on the ethanol, or farmer will produce his self-fuel?
This is exactly the place where we need a lot of institute industry relation where we should develop results on this. What we know so far is ethanol, diesel mixing is a problem. It's not like ethanol, gasoline. Ethanol, diesel is a mixing problem. So you'll have to find additives to see that it's mixing. And then also, if you park the tractor for a long time, what's going to happen? There are a lot of things what we need to debate, discuss, find out, and then implement. So from my perspective, ethanol, diesel is a kind of long topic. Ethanol, gasoline is already done, fine. But ethanol, diesel, there are complications, need to be investigated more.
Yeah, please.
Good afternoon all. I am Rahul Mishra, I am from HCL Technologies. So like the leaders mentioned, Vijay also mentioned about that advanced technologies. Obviously it is mature in US, Europe, but definitely India is, I would say, in the current roadmap. So how do you see the role of technology service providers, engineering service providers, who can help OEMs to bring this scale to India, considering that some of the large engineering service providers are currently located in India and they have already invested in the infrastructure resources. So do you see engineering service providers becoming a co-innovation partner for OEMs to scale these technologies in India?
I've been trying to make that work, haven't succeeded. Large engineering players, I am doubtful because this is does not appear as attractive to them today, right, compared to the other opportunities that are available to them. So, but I've been talking to almost all the large IT players, have given them problem statements, haven't seen anything come back. But having said that, I'm very, very impressed with the pace at which Indian agri-tech is progressing. The maturity of Indian agri-tech in the last 3 to 4 years has been very impressive. I've been talking to them for almost 5+ years. 5 years ago when you spoke to them, they had no clue of what precision ag was, but today you have some very, very cool, impressive working solution. And if you ask me, I'm more hopeful from that segment of breakthroughs coming for India, than some of the larger IT players.
Right, thanks.
Yeah, thank you. Time is Almost 1:45. Okay. So we need to go. Hope, what is it? Yeah.
My name is Dr. Vinay. I am from a company called Mankiewicz, German-based company. I don't have any question for you. I've got one advice for you. Like Mr. Tomar has said, you need to make minutes of meeting or output or outcome of the meeting, and you need to share with him. From my side, we talked a lot on there is disconnect between industry and the institutes. Please make a note and tell him to do like he has to do or government has to do thing so that the interaction can increase. Advice, not question.
Hope, thank you. Hope all the, thank you for the panel members and for audiences also. Hope it is useful. Thank you very much.
Just a small request. The delegates can join for the lunch in the exhibition area, and the speakers can accompany me to the Mahogany Lounge, please. Thank you.